Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 294. It's a medium level problem. The problem name is minimum lines to represent a line chart. So the problem says that we are given a 2D integer array stock prices where stock prices of I denotes day of I and price of I. That means the price of a stock on day I was price of I. Uh, so, and it also says that a line chart is created from the array by plotting the points and on an xy plane with x-axis representing the day and y-axis representing the price and connecting adjacent points. Now, one such example is given in the chart. So it says that okay, you can see that the dots represent a data point, and we connect the adjacent data point, so we get a line chart. So what it says is that we need to return the minimum number of lines needed to represent the line chart. So if we look into the first example, so we can see that uh, though there are 4 points starting from 1, 2, 3, and 4, though there are 4 points, but still these 4 points can be connected by a single line. So it will just be a single line. Then that is represented by a red line. Then we come to the blue one. So again, that's a different line. And then again, we need an extra line to connect the four dots represented by the green line. So total we have three lines. So this is the example. We are given some data points and we need to return the number of lines needed to represent this array. What Let's see the limit. So the limit says that stock prices of length can go up to, so that means we can have 10 raised to the power 5 data points. Each data point will have two values, day of I and price of I, and the value of each of them can go up to 10 raised to the power 9, and all days are distinct. Now, a couple of points to note here is that the days need not be continuous and they can be out of order. Like for example, if we look into the second example, it is 3 comma 4. The first data point is 3 comma 4. That means it tells the data about day 3, and at the second position it tells the data about day 1. So it can be unordered. Also we can see that we have data points for day 3, day 1, day 7, and day 2. So it's not that we have data points for 1, 2, 3, 4, 5, 6, 7. No, we can have non-contiguous data points, and that can be out of order as well. So now let's see how to approach this problem. It's a, I would say, mathematical problem. We need to have an idea of how to calculate the slope. So let's try to understand it. So suppose we have 2 points. Suppose we have 2 points, uh, and we want to connect it through a line. So if we connect it, so this line will have a slope. This line will have a slope. And what is the value of the slope? So the value of slope will be, suppose this point is x2 comma y2, and the first point is x1 comma y1. I think there is some lag in drawing and probably rendering on the screen. So I'll try to explain it a little by taking a little bit of time so that it is rendered on the screen. I don't know what's the issue right now, but again, so this is a line, and we have 2 points represented by x2 comma y2 and x1 comma y1. So if we want to calculate the slope, so it will be y2 minus y1 divided by x2 minus x1. So this will be the value of a slope, right? So this is the slope of this particular line. Now again, if we add an extra point, suppose we extend this line and we add an extra point here, we add an extra point here denoted by x3 comma y3. Okay, x3 comma y3. Now again, if we calculate the slope of this line by picking up either, let's denote it by point A, point B, point C. So if we calculate the slope of line AB, or we calculate the slope of line, we calculate the slope of line using points A and B. We calculate the slope of the line by points B and C, or we calculate the slope of the line by point A and C. The values will be same because all the points lying on a single line, you pick any 2 points on that line and you will get the same slope. So irrespective of which 2 points you choose, either it can be this, choose any 2 points and we will get the slope of that line. So the same slope. So basically slope represents a line in this case, right? So yeah, this is the formula of a slope. Now the question says that we are given some data points, which is day of I and price of I, right? So these can be considered at distinct point. Now we'll be connecting these points, right? So now what we can do is that we know what is the slope, right? So just suppose we pick 2 points. We two first we need to sort the points. Obviously, we need the contiguous points, right? Like for day one here, day two here, day five here, day seven here. These will the points will be plotted like this. So suppose we pick points one and two, like the points for day one and two. So suppose this is this. So we get a slope. We get a slope of the line connecting these 2 points. Now when we pick the next point just after two, so that is five. If 5 lies on the same line, that means we don't need an extra line to represent to connect this point, right? This line chart that we are constructing will just extend this line, and that will connect line number the point number 5. So that means if the slope is same, then we can connect line number 5, point number 5. Now again, the next point after 5 is 7. Suppose 7 is somewhat here. So this is a different line. We can't just extend this line and connect a line, point number 7. Suppose the point number 7 is here, so we can see that the slope of the line connecting points 7 and 5 is different from the slope of the line connecting 5 or 2, or 5 or 1, or 2 or 1, right? So that means as soon as we get a new slope of two adjacent points, that we need a new line to represent that particular point. So that will give us the count of the lines, right? So it will be point. Suppose now I represent it by point A, B, C, and D. So what we do is that first we see what is the slope of first and second point. Let it assume to be slope 1, right? Now if the points are like A, B, C, D, E, something like this, we calculate the slope of point of line represented by AB. Now what we do, we pick C. We calculate the slope of line connecting points C and B. If it is equal to the previous slope, we are good to go. No need to add an extra line. Otherwise, we need to add an extra line, right? Now, so this becomes the new slope, the line connecting B and C. Now we move to D. We calculate the slope of C and D, right? Now if this is same to the last slope, that means the slope of B and C, then we don't need to add a line. Otherwise, if this is different, we add an extra line. So this is the approach that we follow. So I would say, if someone is familiar with this basic mathematics, then yeah, probably the logic will not be pretty tough, but the implementation is something that we need to take care, because when we calculate the slope, like suppose we calculate the slope or using y2 minus y1 and x2 minus x1, so this gives us a slope, suppose s1. Now when we calculate y3 minus y2 and x3 minus x2, and this gives us slope 2, so what will happen, if so this could be a non-integer value, right? This could be a non-integer value, so probably we'll take a double in this case. So because of precision errors, because suppose the first slope is 1.2368, something like this, and the second slope is 1.23672, something like this, right? So if there is a simple precision error as well, then our count can vary. So because we are dealing in double, right? We are dealing in double. So normally in this type of question, a simple hack is that what we can do, we should avoid using double. What we can do is that now we need to compare slope 1 and slope 2. Now what is the value of slope 1? It is y2 minus y1 divided by x2 minus x1, right? Now if this is equals to slope 2, and what is the value of slope 2? It is y3 minus y2 divided by x3 minus x2. If these two are equal, we are good to go. But instead of computing these two values, what we can do, we can cross multiply it, right? What I mean to say, suppose a by b equals to c by d means a into d equals to b into c, right? Either we calculate a divided by b and we calculate c divided by d, and compare those values, or we can compare, cross multiply it, and we can say that a into d equals to b into c. Then also we are good to go. And the benefit here is that we are not dealing with any any, I would say, float or double values. We are just dealing with integers. We just need to take care that it doesn't overflow and we are good to go. So this is the trick that generally we should use. So the logic was that calculate the slopes of adjacent points. That was the logic. And if I talk about the implementation part, then we'll cross multiply and see whether these two values are same or not. So for a two adjacent value, so for two adjacent points, calculate the is instead of calculating the value of slope, keep it in two variables. One is let's call it numerator, one let's call denominator. Numerator will be y2 minus y1, denominator will be x2 minus x1. This is the done. So suppose this is the previous numerator and previous denominator. Now when you come to the new point, calculate the new numerator and the new denominator, right? So this is the current numerator and this is the current denominator. Now the condition that we'll need to check here is that, let me move it, yeah. Now the condition that we'll need to check is that, because the formula is previous numerator divided by previous denominator equals to current numerator divided by current denominator, cross multiply it, condition to check will become previous numerator into current denominator is equals to previous denominator into current numerator. Just check this condition and we are good to go. So now let's look into the code as to what could be the implementation. So if I move to the implementation, the code part, so yeah, this is it. I just added a couple of extra conditions. Probably we can omit it. I just saw that, okay, how many points we have. If that is less than 3, then we return n minus 1. So this is because if we have a single point, so the number of lines required will be 0. If we have 2 points, so we'll need just 1 point. We'll need just one line. So that is why I added this condition. Probably this can be taken care here as well. But yeah. So now we sort the array based on the days. That means we need to sort the points in the order of x-axis, right? Increasing order of x-axis, so that we have contiguous point. Because obviously we'll be continuing, we will be connecting the contiguous points only to make it a line chart. Now we initialize the answer by 1 because we'll need at least one line, and then as explained in the diagram, we'll calculate the previous slope numerator, previous slope denominator. So the first value will be uh, uh, y2 as explained, or I can say y1 minus y0, and this will be x1 minus x0. This is the numerator and denominator. No need to divide it because that will again have precision errors. Now we start traversing from the second index and we calculate the current numerator and the current denominator. So again this will be again the current point, the y index of the current point minus the y index of the previous point, that this becomes the current numerator, and the and the current denominator becomes the current point's x-axis, or I would say x coordinate, and the current and the previous point's x coordinate. So these are the two things. Now we just compare it by multiplying it. I've taken long so that it doesn't overflow, because the range was going up to 10 raised to the power 9. So that was the reason. So previous slope numerator, current slope denominator, and if this is not equal to the previous slope denominator into current slope numerator, we increment our answer, because that means the slope of is not equal. We increment our answer and we just update the previous slope number and previous slope denominator, because we'll be needing these 2 points in the next iteration, and we are good to go. We just return the final answer, and yeah, that gives us the expected one. So I hope you learned something new from this video. We covered a couple of concepts as to how to approach this type of problem. That means calculating the slope. And the second one is that you can use across different type of problem. That logic, that instead of dealing with the double values, we can deal separately with numerator and denominator by cross multiplying the numerator and denominators of the two values that we are comparing. So do upvote this video if you find it useful, and do subscribe to the channel. See you in the next video. Have a good day. Bye bye.